That's cool. Okay. Powers. Powers is just a simple way of writing multiplication. So if you look right here, we have 4 times 4 times 4 times 4, which is kind of crazy right here. And instead of writing it like that, like 4 times 4 times 4 times 4 times 4 times 4, a quicker, easier way to write that is using something called powers or exponents, right? And I think you guys did that before. Remember that from grade 8? Awesome. However many times you multiplied 4, in our case, it was 1, 2, 3, 4, 5, 6 times. That becomes something called an exponent. It goes right there. And we just write it as 4 to the exponent 6. I usually say the words 4 to the power of 6. Same thing. So if I say 4 to the power of 4 to the exponent of, it means the same thing. When we write it, it looks something like this. We call this entire thing a power. This is a power. A power has 2 parts to it. It has a base, the bigger number, and it has an exponent, the little number. This shows you exactly that. The base is 4, the exponent is 6. Hopefully, again, that's some review. And if it's not a review, hopefully it's easy enough that you're just kind of like, oh, yeah, I know what that is. Awesome. An example. So complete the following. We have this right here. We would read that as 3 to the exponent five. You might even hear me say 3 to the power of 5, 3 to the exponent of 5. As long as it's 3 to 5, you're getting it right. You'll be set. So when you see something like that and I read it, that's what I'm reading. 3 to the exponent of 5 is my power. It has 2 parts. It has a base and an exponent. The base is the number 3. The exponent is the number 5. That is terminology you're going to have to get used to. And it's terminology that gets used like all through high school. So when you get to grade 12, they're still going to talk about bases. They're going to be like, the base is, and they're going to say the exponent is. So those are 2 words you're going to have to get down pat. Fantastic. Exponents, or powers, can also be written in different forms. Okay, that would be exponential form. It's written as an exponent. That's this right here, exponential notation. That's when you use an exponent to write out a number. That's like the best way to do it because this is the shortest and I'm lazy. Mathematicians are lazy. We like to write things short and simple. But there is 2 other ways you could technically do it. The next way you could do it would be called factored form. Factored form is when you take something and you break it up into all of its multiplication parts. So if I wanted to take this power and break it apart, instead of it being 7 to the power of 4, I would turn it into 7 times 7 4 times. That's called factored form, as described right here. The third form that we use is called standard form. That's like if you actually calculated the value of something. So if I then went and put this in my calculator, 7 times 7 times 7 times 7, or if I put in my calculator 7 to the power of 4, I would get the answer 2,401. That's called standard form. Again, you will probably be tested on all 3 forms. So they might give you something and say, write it in exponential form, write it in standard form, write it in factored form. And you just need to understand which each form is. Exponential form uses the exponent. Factored form breaks everything up into its individual factors multiplied. Standard form is just the number when you calculate it. Cool. We're going to do a massive chart together with just a bunch of practice to see if we can convert between the 3 forms. Then I'm going to hand over your practice. It's going to be a pretty chill day, pretty easy. The first question, we have exponential form given to us, 2 to the power of 5. We want to write it in factored form. Factored form means breaking it up into all of its multiplication. So this thing would break up to be 2 times 2 times 2 times 2 times 2. Awesome. If you want to do standard form, you just calculate. Again, you have to use a proper calculator. If you have a big one like this, we're not allowed to use these this year. And like the big fancy graphic calculators. This year we use something smaller, like any of these would do. And they're called scientific calculators. Hopefully you have one. If you don't have one yet, I have a couple that I'll pass out if you need to borrow one. If you have one right now, you can take it over. Yeah, that works perfect. That works perfect. Does anyone need to borrow one right now? Let's see how many I have. I can find out. 1, 2, 3. You're right. You can use that other one if you have it. Use that one today. No, that'll be fine. You can use that for now. Just know you'll have to switch it. That's perfect. Yep. That one you can use today, but it won't work in the future. Yeah, that's fine. If you're not sure, you can hold it up. I'll tell you, yeah, it won't work. It won't work. It'll work for today. Yeah. It won't work on tests. That's for sure. You got one? You good? Yep, that works. That works perfect. That'll work. That'll work perfect. If it says TI at the top, well, that's not a good way to do it either.
Mine's TI.
Yeah, that's fine. Yeah, like this is a TI 30, so this one works. As long as it doesn't say TI 83 or TI 84, it should be set.
Why are we not using those?
I think because the bigger ones can do things in the calculator that we need you to be able to do in your head. I think that's the reason why. But I'm honestly not 100% sure. The other reason might be that these aren't required until Math 10C, and not everyone will take Math 10C. So if you went and bought one of these and try to like be like everybody else, these are expensive, like $150 or something like that. So yeah, and then you end up never using it again. That would kind of suck to spend that kind of money. So it might just be a cost efficient thing too.
Can we use calculators?
Can you use what?
Your calculator? You know the ones that have like feet and meters that you can convert them into.
I think so. I'll double check. I'm not sure. Okay, so if you wanted to write this in standard form, you would just go 2 to the power 5 or 2 times 2 times 2 times 2 times 2, whichever you want to do in your calculator. Everyone's calculator is kind of different, so if you know how to use the exponents, fantastic. If you don't know how to use the exponents, then just type the factored form in your calculator. So for me, I'm going to go 2 times 2 times 2 times 2 times 2, and I get 32 as my answer. It would be 2 times 2 5 times, or 2 to the power of 5. So if you know how to use the exponents in your calculator, you can do it that way. Typically, on these calculators, you'll have a button that says like y to the power of x. They'll kind of look like this, y power of x, and that's your exponent button. And so for us, you would hit the number you want as the base first. So I would hit 2, then I would hit my y to the power of x button, and then I'd hit 5, and then I'd hit enter. And that would tell me what 2 to the power of 5 is. I think it's probably easier to punch it in this factor form. It's up to you. Yeah. Awesome. Let's try the second one. So the second one, they've given us exponential form. They've given us a base of 8, an exponent of 3. In factored form, that means we want to do 8 times 8 times 8. So we want to do it 3 times, right? That's what the exponent is telling us, how many times we're doing something. So for us, it'd be 8 times 8 times 8. 500? 8 times 8 times 8, 512? Yeah. Oh, I just didn't hear you say the 12 part. Sorry. 512. That's the standard form. You got it. Awesome. And you should be able to calculate that with us, right? And do it along so you're getting the same thing. Looking at factored form, I'm going to show you something because eventually I'm going to do it and then someone's going to get confused by it. So in math, you know how you guys use the letter X to represent things all the time?
Yeah.
All right, that gets really confusing with multiplication signs. So another way to do a multiplication sign, which is usually the way I do it, is to use little dots. So if you ever see me write this, 8.8.8, that means the exact same thing. It means 8 times 8 times 8. And just because I do a lot of math, typically I'm going to use those dots. And it's just a really old habit. I'll try to use little X's when I can, but it also just goes back to my natural way of using the dots. So it's going to catch my too. Yeah.
Can you please come help me from doing like the standard form, like
Backwards?
yeah.
Yeah, we're going to get there. So you're a little bit ahead of us. You're on this one right here, 36. All right. We'll get there. Yo, wait, sorry. And you're like ahead, you want to go, but I can't. If you look at the second one, we've got factored form here. We want to write it in exponential form. So if we want to go back to exponential form, the base is the number that you're actually multiplying. For us, the base is 7. Because that's the number you're multiplying. The exponent equals how many 7s you have. For us, we have 1, 2, 3, 4 7s, so it would be 7 to the power of 4. The standard form would be 7 times 7 times 7 times 7. It would be 2,401. And 1. The middle one, we have factored form, 12 times 12 times 12. The base is 12 because that's the number that we're multiplying. The exponent is how many times we're multiplying it. We're doing it 1, 2, 3 times, so it's 12 to the power of 3. Again, you put that in your calculator and you get 1,728. Awesome. The last one we're going to do is the hardest one, in my opinion. It's going from standard form backwards into factored form or exponential form. And it's pretty hard. Like it's tricky to figure it out. The best way to get good at them is to just practice a lot with numbers that are called perfect squares, perfect cubes, perfect fourths, and we'll get to that point where we do these a lot, and then you'll be able to kind of see patterns, and it'll become easier. However, since we're not good at them yet, if we want to work backwards from something, the opposite of multiplying is dividing, right? So my goal is to figure out a number that I could divide into 36, that I could keep dividing by that same number until I get that answer. Correct. Divide by 6. So if we tried it and we went 36 divided by 6, we end up getting 6 as our answer. That means I could rewrite this as 6 times 6. Now, there's a lot of numbers I could have divided 36 by. For instance, I could have divided 36 by 2, and it would have got me 18. And then I could have divided 18 by 2, because maybe it still works. And then I would have got 9, and 9 does not divide by 2. Therefore, I couldn't rewrite this as an exponent of 2's. You have to divide by something that would eventually get you to the number you're dividing by. And 6 was perfect. Yeah.
You can just press 1.5 minutes. It'll give you the answer.
Show me which one on yours. That one. Yeah, and that's like, we're going to get to that, and that's called like the square root button, and that would work for this one, but that's only because our exponent was 2. That's why it works. If we want to write this in exponential form, 6 is our base. The number of times we had 6 was 2. Okay, the next one's probably a better example because it's not a perfect square, meaning the exponent's not 2. So I have 1,000. My goal is to divide 1,000 by a number so many times that I get to that same number I'm using. So I'll try 2. just to start off. If I go 1,000 divided by 2, I get 500. If I divide 500 by 2, I get 250. If I divide 250 by 2, I get 125. And if I divide 125 by 2, I get a decimal. As soon as you get a decimal, you know that you don't have the proper base. So you have to try dividing by a different number. And you can keep trying over and over and over again, right? So if I try 3, it doesn't work. If I try 4, it eventually doesn't work. But if I try 10, it eventually will work. So I'm going to just write out what I'm writing here. So I'm going to go 1,000 divided by 10, and I get 100. If I then divide 100 by 10, I get 10, which is the number I'm dividing by. That means I could do 10 times 10 times 10 to get 1,000. 10 times 10 times 10. And I figured that out by dividing until I got the number I was using to divide by. I think that's the trickiest way to go, in my opinion. Standard form backwards is hard. Especially with the big exponents. Like the more times you have to do it, the harder. If I wanted to write that in factored notation, that would be 10 to the power of 3. Because there's 3 10s. Okay, I'm going to give you a minute to try the next 3 on your own. Let's do it. Okay, the next one that we had was 3 over 4. And it looks like people are doing pretty good on 3 over 4. So, or 3 to the power of 4. Remember when you're talking about exponents, you have 2 terms you need to know. One's called the base, one's called the exponent. I have a base of 3. That means I'm doing 3 times. And the exponent tells me how many times. So I'm doing it 4 times. So it'd be times 3 times 3 times 3. That would be 81. Go to the 81. Thank you. Fantastic. Look like people did that one pretty good. And that's like the typical one you're going to see with whole numbers. It's kind of straightforward. It's not too crazy. The next one's a little weird. So the next one is 3 over 5 times 3 over 5. That's the terminology I use, like 3 over 5 as a fraction. What does that, like a fraction symbol, mean? What operation? Yeah, it means divide. And it's funny because like we always seem to forget that. But all this really means is 3 divided by 5 times 3 divided by 5. That's what it's asking you to do. If we wanted to write it as an exponent, the thing that we're actually multiplying by itself is 3 over 5. So my base is 3 over 5. And because it's a fraction, we put brackets around it. We'll get more in depth in the future over why we need the brackets and why the brackets even matter, why do they exist. But for now, we're just going to put brackets around it. That's just going to be the rule. Then I'll give the exponent outside the brackets. The exponent is the number of times you have 3 over 5. I have it twice. Awesome. Standard form. So multiplying those 2 things together to get an answer. You guys typically work better with decimals. I think that's safe to say, right? I know me personally in high school, I did anything possible to get away from fractions because I didn't like it. So I understand if you're the same way and you're like, I don't want fractions at all. So an easy way to do this question would be to change these into decimals. So instead of doing 3 over 5, you could calculate 3 over 5 and figure out it's actually 0.6 and 0.6. And that might be easier to put in your calculator. I think that's what a lot of people probably did. Yeah. And if you're good with your calculator, you'll learn how to work with the brackets. And you could have actually put bracket 3 divided by 5, bracket times, bracket 2 over 5, bracket. Either way, you should have got 0.36. Like that. Cool. That's a tricky one. The fractions always kind of stuff. The next one, standard form backwards. That's the hardest way to go. So to go from standard form backwards, our goal is to divide by something that I can keep dividing all the way until I get that same number. An easier way to actually maybe do that is to keep dividing by the same number until you get the number 1. And that might help you. So for instance, if I go 125 divided by 5, I get 25. So 125 divided by 5, 25. I can then try to divide by 5 again. Divide by 5. And I get 5. I can divide 5 by 5 till I get 1. So it might help if you think of it as I just always want to get to 1. And if I can't get to 1 or I start getting decimals, then I stop. The reason this way might help is it makes it a little more obvious what your exponent should be. So the base is 5 because that's what I'm dividing by. And the exponent is the number of times I divided by 5. I did it once, twice, 3 times. My exponent would be 5 to the power of 3. So if it helps to just divide till you get to 1, do it that way. If you're getting it without doing that, that's fine. My middle number would then be 5 times 5 times 5. Yeah, for sure. All right, the next one. We got brackets and fractions again. So remember, exponents are just telling me something multiplied multiple times. My base for this question, the thing I'm multiplying, is 1 over 2. That's my base because it's inside the brackets. So that means I'm going to have 1 over 2 times. And then my exponent tells me how many times I want to do that. For us, it's 3. So I'd have 1 over 2 times 1 over 2 times 1 over 2. Now I saw some people change it to decimals. So they changed 1 over 2 to be 0.5. And you went 0.5 times 0.5 times 0.5. You're right. Like that works too. The fractions is probably how you'll see it on a test. Right? They like to leave it as fractions. So it might be wise to leave it as a fraction. However, if it helps you to change to a decimal to calculate it, that's okay. Yeah.
So is it still right if you have it as a fraction?
So you have, like I have it right now?
Yeah, like at the 36 question.
Did you have,
9 over 25, so is that still right?
That's even better. Yep, that's perfect. So if you have this fraction for this answer, that's fine too. You just, different form. And we haven't really talked about multiplying fractions yet, so there's not too much stress there on which form you're in. Cool. Converting this one to standard form. You have 1 over 2 times 1 over 2 times 1 over 2. That's 0.5 times 0.5 times 0.5. And you should get 0.125. If you're doing decimals. If you're doing fractions, the way you get fractions is you multiply all the top numbers together. So I would do 1 times 1 times 1 to get 1 on the top. And on the bottom, I would do 2 times 2 times 2 to get 8 on the bottom. That's how that works if you want to keep it as a fraction. Multiply all your tops, multiply all your bottoms. Perfect. The next one. We got decimals, so that's nice. Did anyone change the decimals to fractions? Magnus. Good. It's a decimal. Leave it as a decimal. Make your life easier. So you got 0.2 times 0.2 times 0.2 times 0.2. The base is 0.2. The exponent is how many times. I did it once, twice, 3 times, 4 times. So it's 0.2 to the power 4. If you put that in your calculator, I don't think I can do that one in my head. So I'll try it. 0.2 times 0.2 times. Oh, perfect. 0.0016, right? Yeah. Thank you. I would not have got that. Yeah.
I'm just curious what's up, because when I did that on my calculator, it said 1.6 times 10 with a -3 right above it.
Oh, okay. So you're getting like scientific. Did anybody else do that? A couple? 3 people. So your calculator is just in a different mode. It's probably called like scientific notation. I'll come to each 3 of you and see if I can change it so it gives you just a straight decimal. So you don't get that problem anymore. Did you have that problem too?
No, can you see if this one's right
Which one are you on?
though?
I don't know what decimal. I can't do that in my head. Okay, so those of you who had that scientific notation part where you got 1.6 and then it said something -3, I'll come help you 3. If anyone else had that problem with that calculator, just let me know and I'll fix it for you. And if not, then I'll show you how it works. Cool, 49. So we want to work backwards from 49. Trying to find a number that divides into 49 is actually hard. What number divides into 49? 7. Perfect. So that's the only number that divides into 49. And if I divide it by 49, I could do it twice. So I would get 7 times 7, which means I have 7 squared. That's a hard one, right? You're working backwards. You would have had to try a lot of things that failed, right? 7 divided by 2, divided by 3, divided by 4, divided by 5, divided by 6. It's a lot of things before you get to the right answer. Cool. 16. Now, 16 could be broken into 2 different factored forms. However, they give you a hint over here. They give you 2 with a little empty box. What they're telling you is that the base should be 2, meaning that you should be dividing this by 2. Then you have to pick an exponent. So how many times did I have to do 2 times 2 times 2 times 2 until I got to 16? How many times did we do it? 4. Yeah. So the other popular answer I saw, looking around the room, was 8. And we have 2 popular answers. We have 4 and 8. 2 different trains of thought. Exponent tells me how many times I'm multiplying the number 2. So I want to multiply the number 2 4 times. Those of you who put 8, what you did was 2 times 8 equals 16. You figured out 2 numbers that multiply to be 16. Not how many times the same number could multiply over and over to get to 16. And that's the trick, right? Like that's where people get exponents mixed up. They end up multiplying by the exponent instead of the number of times by the exponent. Okay, the last 2 were probably the hardest. 1/4 cubed. 1/4 means 1/4, so 1/4. That would have been my base. If you put 0.25, that's okay. Cubed means exponent 3. So that's like some good math terminology. It's probably been a while since you guys have heard that terminology. But 1/4 is 1/4. Cubed is 3. In factored form, that means I would have 1/4 times 1/4 times 1/4. If you put 0.25 times 0.25 times 0.25, that's fine. I'll give you a second to write that down because that was a hard one. If you put that in your calculator, you would have got 0.015625. Those of you with the scientific notation, you probably got like 1.56 times 10 to the power something or something like crazy like that. Or did it actually work for you guys this time? It worked. Weird world. As a fraction, so those of you who are doing fractions, you would have got 1/64. Awesome. Our last one. We have 216. They give us a hint. The hint is that you should have to divide it 3 times by a number. Did anybody get a number that they could divide 3 times?
6.
6? So let's try it. 6 times 6 times 6 gets you 216. So that is perfect. And again, it takes just a little bit of guesswork. That means 6 times 6 times 6. Was that the right answer? The 0.122, the one you asked me about?
No.
No, I can't do that in my head. That's too hard. Okay, so key concepts we learned today. A power has two parts to it. It has a base and an exponent. And then powers can be written three ways. Exponential form, factored form, standard form. And you can change the three. Beautiful. I'm going to hand you out